So I know we have done solving systems before, but I'm just showing you another way. One man's way, you could say, well, I like this way better than this way. Okay, fine. It's just another way to solve a system. That's all. That's really what Matrices helps us with. So I'm actually going to start us with an easier one, and then we'll do a harder one. And then if you saw in tonight's homework, I'm only giving you 4 problems. 2 you have to do by hand. 2 you can do in the calculator. So really, you're only doing 2 problems. So if you keep complaining and crying about it, it's just going to be the way it is, y'all. Okay? It is what it is. So this is our first example. You're going to do 2x plus 3y equals 9 and 5x minus y equals 14. And I'll be honest with you, I am so good at solving a system by hand, like doing the elimination method, that I would never have even thought to do it this way, but I'm going to do it this way anyway, just to show you. Okay? What? That you're kind of concerned about first. This is the 2, 3, 5, and -1 matrix. We'll call that A. Okay. And we are going to find, and this is the first thing you have to do, is you just find the determinant of A, just like you normally would. Okay. Call this A. And since it's a 2 by 2, this is super easy. So you would just do, crisscross. What's that? -2 minus 15, which is -17. Yeah. All right. Keep that in your little brain there for a second. Now you are going to write 2 new matrices, one for the X and one for the Y. So here's what I mean. You're going to have, and we're going to call it an AX matrix. That's just a little symbol for what we're about to do. So kind of pay attention to what I do, and then I'll explain it. You are going to take this part right here, the matrix that it's equal to, and you are going to replace that. This is your X column, right? These are the X's. These are the Y column. You are going to replace that into the X positions. So literally, you're going to take away 2 and 5, and you're going to put 9 and 14. And you're going to write a new matrix. So you're going to have 9, 14, 3, and -1. Do you all see what I just did? Okay. So again, I took the equal part and I replaced that into the X. And I created a new matrix. Now, find the determinant of that new matrix. What would the determinant of this one be? Well, this would be -9 minus 42. And what is that? -51. Okay. Take your -51 and divide it by the original determinant. And what do you get? What's 51 divided by 17? Anybody know? 3. That is your answer for X. That is the X equation solved. Now, you can do that again for the Y and make a Y matrix. Guess what the Y matrix would look like? 914 would not be here. 914 would be now, right. 2 and 5 would be remain. 9 and 14 would now be replaced in the Y column. And so, and then again, do the determinant like you just did before. So this would be 28 minus 45. What's 28 minus 45? -17. Yeah. And what's -17 divided by -17? 1. 1 is what Y is. So your solution to this system is 3, 1. Again, would I ever have done it that way in my life? No. Why did people make this up? This is why they made it up back in the day. They didn't have the calculator, the beauty of it all. Solving it by substitution or elimination, I think, is much faster because I'm just used to it, but just another way to do it. I mean, that wasn't really too bad. But you ready to do it for a 3 by 3? Yay, let's do it. Thank you. Excited. Okay, so your matrix A would be what?
2, 1, -1, 3, 2, -4, 1, 6, -3.
Correct. Okay. The first thing you have to do is you have to find the determinant of A, of that matrix right here, without the equal part replaced into it. So you would say, okay, the determinant of A, and I'm going to do it, Mr. Belk's way, which I've been getting used to. I'm not as fast, but I'm getting used to it. And if you don't remember what he does, he just took the first two columns and you transpose them. So you move them over 2, 1, 3, 2, 1, 6. You only have to do this for 3 by 3 and higher. And then you multiply all of the left diagonals, and there will be 3 of them. And then you can write those numbers on the bottom. So -12, -4, -18. And then you multiply all the right diagonals together. -2, -48, -9. And you always have to do left diagonal minus right diagonals. So you take these bottom numbers, which are your left diagonals, and you minus every one of the right diagonals, which changes their sign. So really it would be +2, +48, and +9. And you'll get out 25. And that is the determinant of A. That's what we're going to divide every one of the X's, the Y determinants, and the Z determinants. Again, this time you have to make 3 matrices, but really you don't have to. You could just make 2 matrices, and once you find an X and once you find a Y, you could just plug it back in here to find the Z. You could do it that way, which some people in the other class were like, yeah, that's the way I'm going to do it. I'm fine with that. So now you're going to create this new determinant of what's called AX, okay? And again, where am I getting this AX from? I am taking this -13, -36, and 12, and I'm going to replace it into matrix A, into the X column. So no longer will I have 2, 3, and 1. I am now going to have -13, -36, 12. The other two, the X and Y column over here, are going to stay the same. 1, 2, 6, -1, -4, -3. And then I'll transpose those two columns. And I'll do the determinant again. This is why Mrs. Setta only gave you 2 to do tonight. Thank you. -48. $216. And we'll go this way. So that'd be -24. 24 times 13, 312. $108. And then just don't forget that you're always doing the bottom 3 numbers, add them together, combine them together, and then subtract the top. So change the signs on the top. So +24, -312, -108. And hopefully we get out an answer. 216 plus 24. Yep, -150. That is not your answer. What do I have to do with -150? Divide it by the original determinant of A. So your answer is -6. That is your X value for that system. Yes.
Miss Davis shows up and it's like
multiply and then like multiply by the.
A inverse B?
Yeah.
Yeah, that's the calculator way, which I'll do after this one. All right. So again, what I did was I replaced what it equals and made a new matrix, okay? And then you could do the same for Y, and then you could figure out Z. Let me just see you make determinant AY. Let me see what your AY would look like, just to make sure you know what you're talking about here. What would your AY look like? Hint, hint, hint. These should be in the middle column. These two columns will be whatever the original A was. So that's what your AY would look like. And then to actually solve it, you would transpose the two columns and do the whole left diagonal, left diagonal, left diagonal, right diagonal, right diagonal, right diagonal, okay? But I'm gonna let you just enjoy doing that today for homework as part of your joy. I believe you'll get Y to be 7 if you try it out, okay? So nothing too really bad here, except and you're probably like, well, I would rather do it the other way. Fine. I mean, that's great. Do it the other way. But this is just another way of solving a system, a multivariable system. And especially when you get to like WXYZs that you have to solve for, matrices really do help. All right. And then one more thing I just want to show you is using the calculator if you're given or allowed to use a calculator, solving system with the graphing calculator. And I'm actually going to do that same one, 2x plus y minus z equals negative 13. Equals negative 36, and x plus 6y minus 3z equals 12. Okay. Now, Miss Davis did A inverse B, and you can, again, I'm fine with you doing A inverse B if that's the way you want to do it. I'm just going to show you a totally different way of doing it that I think is a little bit easier, because that's just how I've done it. I actually create one big long matrix. I don't create the A and then I don't create the B. I just actually put them together. And I write 2, 1, negative 13. 3, 2, negative 4, negative 36. 1, 6, negative 3, 12. In mathematics, there's actually a dash line here. This is called an augmented matrix. Augmented because you're putting the equal sign inside of the matrix itself. Okay. Then what you're going to do is you're going to go into your calculator and you're going to go into the matrix formula and you're going to edit. I'm going to do it into B. I'm going to arrow over and go to edit. I'm going to edit matrix B because I just want to do it into B. This now is a what by what matrix. So I'm going to type 3 by 4. I'm going to type in all these numbers, 2, 1, negative 13, 1, 6, and negative 3, 12. Let me make sure I type it right because I always mess it up and type it wrong. 3, 2, negative 4. Okay. Then go back out, back to your home screen, go back into matrix, go over to where it says math, because this is all your math. This is like the determinant button and everything. You're going to go up and go to where it says RREF, okay? RREF, not REF, RREF. What that stands for is called reduced row echelon form. You're going to hit enter. And then you're going to tell what matrix you want it to RREF. I'm going to want it to go back in and do B. So I'm going to RREF B. And then hit enter. And what you get out, if you did it correctly, is you get the identity matrix in the first 3x3 part, and then you get out this last column of numbers. Take a guess what those last column of numbers are. That's the X, Y, and Z. If, however, you got out like 100, 010, I'm sorry, 011, and then maybe 000 down here, you would have like a no solution problem. Or you typed it in wrong, because you can have no solutions that work out. But that, I just think that's sometimes quicker rather than doing A inverse B. A inverse B uses 2 matrices. This just uses 1. So if on the SATs, guys, if you're taking that this Saturday and they allow you the portion, they have something of system, put it in the calculator, do the matrix operation right away. RREF. But that's all you have to do. So for homework tonight, you just have to do